an artist concept depicting one of NASA's twin Voyager spacecraft, humanity's farthest and longest-lived spacecraft, which celebrated 40 years in August and September 2017. The Voyager mission team fired up a set of 4 backup thrusters aboard the Voyager 1 spacecraft last Tuesday, November 28, 2017. The thrusters had been dormant since 1988. If you tried starting a car that had been sitting that long, you might not expect it to respond. But on Wednesday, November 29, mission controllers learned that Voyager 1's thrusters did respond. Suzanne Dodd, project manager for Voyager at NASA's Jet Propulsion Laboratory JPL in Pasadena, California, said with these thrusters that are still functional after 37 years without use, we will be able to extend the life of the Voyager 1 spacecraft by 2 to 3 years. Voyager 1 was launched in 1977. It's the most distant spacecraft from Earth and likely to remain so. It took advantage of a cyclical positioning in the outer planets, during which they were all temporarily on the same side of the Sun, and thus passed Jupiter in 1979, Saturn in 1981, Uranus in 1986 and Neptune in 1989. Voyager 1 was judged to have crossed the heliopause on August 25, 2012 to enter interstellar space, the space between the stars. Here are 4 of the 5 spacecraft headed out of the Solar System. New Horizons is also headed outward, but it's just past Pluto and not depicted here. Image via Wikimedia Commons. Click here for a list of spacecraft leaving the Solar System. This artist's concept puts Solar System distances in perspective. The scale bar is in astronomical units: 1 astronomical unit, 1 Earth's distance. Each set distance beyond 1 astronomical unit representing 10 times the previous distance. Voyager 1, humankind's most distant spacecraft, was at a distance of 138 astronomical units, 12.8 billion miles, 20.6 billion kilometers from the Sun as of early 2017. Image via NASA Caltech. Both Voyagers carry a golden record, intended for retrieval by intelligent extraterrestrial life forms, or for future humans. The records are meant to serve as a time capsule, depicting images and sounds of Earth at the time the Voyagers were launched. Read more about the Voyager's golden record. The spacecraft relies on the thrusters to orient itself so it can communicate with Earth. These thrusters fire in tiny pulses, or puffs, lasting mere milliseconds, to subtly rotate the spacecraft so that its antenna points at our planet. A statement from JPL said since 2014, engineers have noticed that the thrusters Voyager 1 has been using to orient the spacecraft, called attitude control thrusters, have been degrading. Over time, the thrusters require more puffs to give off the same amount of energy. At 13 billion miles from Earth, there's no mechanic shop nearby to get a tune-up. The Voyager team assembled a group of propulsion experts at NASA's Jet Propulsion Laboratory, Pasadena, California, to study the problem. Chris Jones, Robert Shotwell, Carl Guernsey and Todd Barber analyzed options and predicted how the spacecraft would respond in different scenarios. They agreed on an unusual solution: try giving the job of orientation to a set of thrusters that had been asleep for 37 years. On Tuesday, November 28, 2017, Voyager engineers fired up the 4 TCM thrusters for the first time in 37 years and tested their ability to orient the spacecraft using 10-millisecond pulses. The team waited eagerly as the test results traveled through space, taking 19 hours and 35 minutes to reach an antenna in Goldstone, California, that is part of NASA's Deep Space Network. Lo and behold, on Wednesday, November 29th, they learned the TCM thrusters worked perfectly, and just as well as the attitude control thrusters. This picture of a crescent-shaped Earth and Moon, first of its kind ever taken by a spacecraft, was recorded September 18, 1977, by Voyager 1 at a distance of 7.25 million miles, 11.66 million kilometers from Earth. The Moon is at the top of the picture and beyond the Earth as viewed by Voyager. Image via NASA. Jones, chief engineer at JPL, said the team had to look back at historical data to devise its plan to use the thrusters. The Voyager flight team dug up decades-old data and examined the software that was coded in an outdated assembler language to make sure we could safely test the thrusters. Barber, a JPL propulsion engineer, commented the Voyager team got more excited each time with each milestone in the thruster. The mood was one of relief, joy and incredulity after witnessing these well-rested thrusters pick up the baton as if no time had passed at all. JPL said the plan going forward is to switch to the TCM thrusters in January. To make the change, Voyager has to turn on one heat per thruster, which requires power, a limited resource for the aging mission. When there is no longer enough power to operate the heaters, the team will switch back to the attitude control thrusters. The thruster test went so well, the team will likely do a similar test on the TCM thrusters for Voyager 2, the twin spacecraft of Voyager 1. The attitude control thrusters currently used for Voyager 2 are not yet as degraded as Voyager 1's, however. Voyager 2 is also in course to enter interstellar space, likely within the next few years. In early 2017, astronomers spoke of using the Hubble Space Telescope to provide a roadmap of the Voyager's trip through interstellar space. This artist's concept depicts the paths. In the illustration, Hubble is gazing along two sightlines, the twin cone-shaped features along each spacecraft's path. Each sightline stretches several light-years to nearby stars. Image via NASA, ESA, and Z. LAVASTSCI. Read more about this image. Bottom line, space engineers devised and successfully carried out a plan to fire up thrusters aboard Voyager 1 needed to communicate with Earth, thus extending the life of the mission by several years.